conference, Artificial Intelligence, Technology and Future of Sindhi Language, to share my insights on a topic incorporating Sindhi language resources into Stanza NLP pipeline, enhancing NLP capabilities. So basically, we are adding tools and data for the Sindhi language into Stanza system. This will help machines to better understand and process Sindhi language, making it easier for the technology to process with this language. These are the topics I will be covering today: introduction, problem, NLP pipeline, methodology, results and discussion, and in the end, conclusion and recommendations. Starting the introduction with NLP. So what exactly is the NLP? Before we talk about NLP, let's discuss how humans talk and interact with each other. Humans communicate with each other mostly via text or speech. The human's way of communication is called natural language. But to make it understandable to the machines, NLP comes into picture. NLP stands for Natural Language Processing. It is a branch of artificial intelligence that focuses on the interaction between humans and computers using natural language. So it will help machines to interact with us in our own language and making the technology more intuitive and more friendly. Some of the applications of NLP are, as you can save millions in terms of manpower and time with the NLP applications, such as you don't need to always have a person present at the other end of a phone. An application of NLP chatbot is used to simulate human-alike conversation with the user via text. Don't know how to spell a word correctly? Autocorrect has you covered. Another applications of NLP are speech recognition, which is used to identify words spoken aloud and convert them into readable text. And one of the applications of NLP is sentiment analysis, which is used to determine whether the data is negative, positive, or neutral. So the NLP pipeline is a series of steps and stages that are applied to the text data to extract some useful information and to perform some specific tasks related to the NLP. So some of the typical stages are shown in this picture. As from the beginning, we have a raw text. The raw text is given as an input to the first model, tokenization. Tokenization will perform some algorithmic calculation. Then the output of tokenization model will be given as an input to the next model. And this chain goes on till we get a file that is understandable by the machine. This is how NLP pipeline works. And we can also customize the pipeline according to our needs. Some of the popular NLP pipelines are Stanza, Spacey, NLTK, Transformers, Core NLP, Text Block, Janism, Flare, NLP, Open NLP, and Rasa NLU. So in the realm of NLP, where major languages like English have seen extensive development due to the availability of vast text corpora, there exists a significant gap when it comes to low-resource language. Sindhi, for instance, is one such low-resource language. This means that Sindhi, despite its rich cultural significance, lacks computational tools and linguistic data required for advanced processing. So, and many NLP libraries tend to overlook these languages. So it's crucial to recognize and address the disparity that Sindhi language is not supported by any current NLP pipeline. So the aim of my research was to add Sindhi resource languages into one of the well-known NLP toolkit, Stanza's pipeline. So the tool we use is Stanza. Stanza is a Python-based NLP toolkit that was created by an Stanford NLP group. It is open source, and it comes with pre-trained models for over 60 languages. It has two main components. The first one is neural NLP pipeline, which means that the pipeline of Stanza consists of tokenization, multi-word token, lemmatization, part-of-speech, dependency parsing, and named entity recognition. And the another component of Stanza is Python interface to the core NLP Java package for additional functionalities. We have a demo of Stanza. Consider the raw text, Shazia Karachi mein रहंदी आहे. The first step of NLP pipeline of Stanza is tokenization. The tokenization will split the sentence into smaller words or tokens, such as the following sentence, Shazia Karachi mein रहंदी आहे, would be tokenized into 5 tokens. Then Stanza will assign each word a part of speech, such as Shazia is a proper noun, Karachi is a proper noun, Ma is adposition, Rahandi is a verb, and I is the auxiliary verb. Then each word returns to its base form, such as the base form of Rahandi is Rahan. Then dependency parsing parses the sentences for syntactic correct structure, and in the last, named entity recognition identifies the named entities in the given text, such as person's name, location, title, organization. In this case, Shazia would identify as a person's name and location, Karachi as a location. As compared to other famous NLP toolkit, Stanza supports over 60 languages and it offers state-of-the-art performance, which means that it achieves highly accurate and effective results in performing NLP tasks. Methodology. Following are the steps to integrate Sindhi language into Stanza toolkit. As we begin with data collection, the data is gathered from different sources in Sindhi. Then once we have the data needs to be pre-processed to make it suitable for machine learning. Then data model specific to Sindhi language is developed. And once we have the data and data model, the model is trained, and the final step involves integrating it into Stanza. As I have trained 2 of the models of Stanza, tokenization and named entity recognition, so let's discuss them. The first model is tokenization and sentence segmentation. So it is a process of splitting the raw text into list of sentences and list of sentences into list of words. So the sentence Munja nalo Sakina would be tokenized into 4 tokens. The data is collected from some news article and stories in Sindhi. For Stanza, the data needs to be in 3 formats: raw text, list of sentences, and list of tokens. Then the data needs to be pre-processed according to Stanza toolkit. The data needs to be in a specific format, co-NLU format. So the data is converted. After conversion, the data is split into 3 sets: training set, development set, and test set. So training set is a set of data that is used to train the model and make the model learn the hidden features in the text. Development set is a set of data that is used to evaluate the performance of a model during training. And test set is a set of data that is used to test the model after training. We trained our model, and the evaluation metric that we have used is F1 score. In development set, the F1 score for token is 99.94, and for the sentence, F1 score is 96.57, and F score in test set is for token 99.96, and for sentence 95.43%. Another model that I have trained of Stanza is named entity recognition model, which is basically a process of identifying the named entities, such as organization, title, person. So for this model, the data that I have used is from Ali Wazir, Sindhi named entity recognition data set. I trained the model and I got the accuracy 84.27. And also we can see the number of correct and incorrect prediction made by the model. And for this, the evaluation metrics are precision, recall, and F major. Precision we got is 87.10, recall is 80.26, and F major is 84. So I'm pleased to announce a little achievement that with the collaboration of a researcher of Stanford NLP group, the model we trained has been successfully incorporated into the Stanza toolkit officially. And Based on that, it can be concluded that the pre-built-in models of Stanza can be effectively trained for Sindhi language. And as we can see, the accuracy of tokenization model shows that it is highly accurate, whereas the accuracy of named entity recognition is not so high. So we can always train the model with more data. As we know, the larger and the most diverse the data set, the better the results. So for the future, we can always train other models of Stanza, and we can create a standard corpus for Sindhi, and also we can create NLP application specific to Sindhi language. Thank you.